All right, next up was Sandy. Hello, hello, welcome.
Hello. Excellent. Welcome. My name is Sandy Steier. I'm CEO and co-founder of 1010 Data. What was that? Is it working?
I don't know if we can hear you. So try again. Genies. Try again, Sandy.
Hi. Great. Oh, better. I don't know what I said before, but I'm Sandy Steier, co-founder and CEO of 1010 Data. We're a company right here in New York. And what I wanted to talk to you this evening about was a bunch of things. I'd like to talk about big data and small data and spreadsheets and data warehouses and data discovery and business intelligence. I'd like to talk about the past and the present and the future. So with that, this is my obviously somewhat schematic view of the past. It's based on my own experience, and you know, it's not meant to include every detail, but it includes enough details and the essential information that I think would be valuable for this discussion. And just to let you know, where this discussion is going is I'd like to introduce a concept that I think will be, somewhat interesting. So what happened was, when I first started, there was no such thing as software per se. There was some software that was sold by IBM and other companies like that, but basically you did all the work yourself. You know, a programmer went and did all the work. They built a database such as it was. They did all the analysis. They did everything themselves. There was very little visualization. In fact, when I started, there was punch cards, so that's no visualization. But you know, pretty quickly we had IBM 3270 terminals, which had a limited amount of visualization, and that's what you did. In the early 80s, at least two things happened, which fundamentally changed the world, and I think that there was a certain split that happened at the time. First of all, spreadsheets came on the scene. And so some of the work that programmers would do in terms of basic analysis no longer needed to be done by programmers. Business people could do it themselves. That was really nice. But spreadsheets couldn't handle data analysis, not unless you're talking about little tiny data. And so, fortunately, perhaps, at the same time, relational databases came on the scene. And relational databases became the technology of choice for keeping large amounts of data. You can think of it as big data on the left and small data on the right. Very small data and potentially very big data. Big data nowadays is used in all sorts of different ways. I'm using it here mostly as big. You know, there's many ways to describe big data. Let's talk about big data. And there was always big data. There's bigger data today, but once upon a time, 30 years ago, smaller data was big data. So we started with the relational database, and over the years, things changed. 10 years later or so, approximately, the concept of a data warehouse was introduced. The idea that you should have a data-centric store for your data so that every application can use the same data. It should be done in a certain way. And now, we're sort of replacing parts of that stack with newer technologies. And in particular, this sort of the database engine itself is being replaced to a certain degree with things like Hadoop. Hadoop can be used in other areas as well, but I think this is an important case. On the right side of the sort of evolutionary process, nothing really much happened, at least nothing so interesting happened for many years. Now, data discovery is becoming a big thing. The first presentation tonight was essentially a kind of data discovery tool. There are many other examples of that. That's becoming a familiar term. The term itself, data discovery, is only a couple of years old or so. But it serves an interesting purpose. To some degree, that idea existed way back when. I mean, people were always interested in doing things, and spreadsheets were a kind of data discovery tool. Data discovery, for those who are not familiar with the term, basically refers to the ability for non-technical people like business analysts, people in marketing, in merchandising, in finance, to do their own analysis. And so Excel served that purpose for many years. It has limitations, and now there's many new things coming out to do that. So that's great, but where has that left us? It's left us with a suboptimal situation, I think. I think that the example I have here is one of, you can make your own example up. I'm sure you all have experienced this sort of thing. But you can't actually analyze the data in the data warehouse directly, at least not a business person can't. And also the data warehouse is not capable of doing very large analyses for just, on a whim by anybody who might happen to ask a question. And so you've got to do extracts of the data, and you've got to send it to the analyst, and then it turns out the data may be wrong, and you've got to send it back, and then you finally get the result, and the person who asked the data has a different question, perhaps as a result of the first question or because they didn't communicate it right the first time. And now you've got to start all over again, and it takes a long time, and you could be literally, and this is something we hear every single day. I heard it today from some analysts I spoke to, that it takes weeks. It never takes weeks to do something in Excel per se. I mean, you could use Excel as a tool and spend a lot of time, but the actual, you run something in Excel, it doesn't take weeks. And this is a problem that exists up and down the so-called stack. The stack, which is a database in the middle, and it's data integration, ETL tools to get data into the database, and business intelligence tools to get data out of the database, and analytical tools to do more sophisticated analyses. And there's problems all over the place. If you want something new, you want to use some sort of new data, mashups, getting it into the data warehouse is a non-trivial process. And it really doesn't work that efficiently. We could sort of summarize the situation this way. On the one hand, the data warehouse sort of branch of the tree, which, by the way, is the branch that IT sort of began to own after Excel came on the scene. I mean, I remember people in technology didn't like Excel when it came on the scene because partly because, for valid reasons, there's some issues with Excel, spread marks and whatnot, but a lot of it had to do with their own careers. But IT could handle at least the big data part. That was certainly their domain. So the big data part handles big data. But it's complicated. That's a negative. It takes a long time to set up. If I have a new data set, somebody hands me 10 billion rows of data, and I want to do an analysis on it, to get a data warehouse up and running or to add that to an existing data warehouse is a non-trivial thing to do. It takes a long time. There has to be a lot of collaboration between a lot of people, not just business and technology people, but different people within the technology organization. It does have strong enterprise control over data, so that's a good thing. Spreadsheets have a little bit of an issue there. It's not flexible as in terms of adding new data and whatnot, and in terms of the kinds of queries you want to ask, because data warehouses are usually designed for certain kinds of questions. The data is summarized a certain way, it's presented a certain way, and if you try to ask questions that it wasn't designed for, either it can't answer them or it takes forever. And we already talked about mashups. And so what happens nowadays is that, and this is basically, if you look at the sort of big data and business intelligence and data discovery market, it's all about how do I deal with this, with these two things. On the one hand, I'd like to look at really big data, and I'd like it to be really easy, and I'd like to do data mashups. And on the other hand, I'd like to deal with big data. And I want to make sure I have some controls over it, and they're not really compatible things the way we've evolved. So what I'd like to do is go back to the history and say, well, why are we where we are? And that may be a strange question, but you'll see where I'm going. Why was that? Why did that original branch happen? Now, there are many reasons for everything in the world. So this is not the only reason. And this is such an obvious reason, in fact, that many people wouldn't even think of it as a reason. In fact, many people don't even think of, like, what does spreadsheets have to do with databases? I mean, what does one thing have to do with the other? Why would you ever think that they would be at all similar? I mean, that branch is obvious and arguably, inevitable. I think it's because spreadsheets couldn't handle big data. Now, that's a very peculiar thing to say. And another way to say that is, if spreadsheets could handle larger amounts of data, would things have evolved the way they do? Now, again, that's a very peculiar question. It's a question that normally people wouldn't ask themselves, but for whatever reason, I've been asking myself that question. So I'd like for you to think about the following thing. Imagine you're a data analyst, or somebody who has a lot of data to analyze, whatever it is. And you have, the example I give, well, 1,000 rows of data. Would you build a data warehouse? I think most people here probably know enough about data warehouses to know that the answer is no. 1,000 rows of data, you take Excel, you stick it in Excel, you do whatever you need to do. Easy, quick, you're done by the end of the day. If you had 10,000 rows of data, would you build a data warehouse? No. It's 10 times as much, but you still wouldn't do that. If you have 1 million, Excel doesn't handle 1 million rows of data very well, but there are other similar kind of tools, maybe Tableau or something like that do handle larger amounts of data, and you could do it that way, and again, you're up and running pretty quickly. 1 billion, you're beginning to run into issues. There are some tools, perhaps, that can do that, but again, there are limitations. And so you wouldn't do it, so you'd have to switch to some other mechanism, and so you'd have to basically buy a database of some sort. You could buy maybe a less sophisticated, less expensive one to start, and use that, and that's fine. But then as the data goes bigger and bigger, you have to buy more robust databases, bigger databases, more hardware, et cetera, et cetera. So the reason why you switched from spreadsheets to databases, which is a completely different kind of thing, right, is because of spreadsheets couldn't handle the larger amounts. But what if spreadsheets could handle unlimited amounts of data as easily as Excel handles 1,000 rows of data? Suppose that were true. I mean, it's hard to imagine. It's a little weird. But suppose it could. Then if you had 10 million rows of data, would you build a data warehouse? Certainly not. What about 1 billion? Why would you? What about 1 trillion? Why would you? What's the difference between 1,000 or 1 million or 1 billion or 1 trillion? It's just some zeros. I mean, if the kind of analysis you want to do is doable with a spreadsheet, then you wouldn't build a data warehouse. Now, I know there are other advantages that data warehouses happen to give. Data governance, more control over data, things like that. But going back in history, if in the early 80s, if we could go back and go into a time machine and deliver to the past a spreadsheet that worked on unlimited amounts of data, would things have happened the way they happened? Yes, somehow data governance would have to be taken care of. I have answers to all these things, but I'm not going to get into all the details. Somehow these things would have to be taken care of, but I guarantee that the data warehouse stack would not look like it looks today. I think we can probably all agree on that. So what does it mean for the future? If that's the case, if in the past we know that we wouldn't be where we are today if spreadsheets worked, the way they do, or some other data discovery tool. If a self-service, something that a user could just, pull out their laptop and do whatever, if there were no laptops in the early 80s, but, somebody could just pull up a computer and do the thing just in Excel without having to talk to anybody about it and get it done, we know that things wouldn't look the way they look today. So what about today? The fact is there are tools that do that today. And, you could not believe it, but that's why we're about to do a demo. And it is possible to have a data discovery-like, user-friendly, spreadsheet-like tool that can handle any amount of data and can give the responsiveness of something like Excel, and is actually capable of far more sophisticated analysis than Excel could ever do in terms of level of analytical sophistication. So where do I think that I think it's inevitable, given the fact that we agree on the past. I think that, in fact, data discovery, which is becoming more and more robust and taking over more and more of sort of the stack, I think it could take over the entire stack. We'll actually replace the stack. You don't really need that. And if you have something like a big data discovery, big data discovery tools available, it changes the game rather dramatically. And things will be different. And 10, 20, 30 years from now, people won't be, there'll be some other questions about what we did wrong over the next 20, 30 years. But going back, when they go back to 2014, they'll realize that things began to change, or perhaps before, perhaps a little bit later, depending on how quickly it changes. Things will have changed by that time. I think this is inevitable. Now, again, because it's a peculiar concept, the notion that a data discovery spreadsheet-like experience kind of tool could actually handle unlimited amounts of data, we'd like to do a demo. My colleague Owen Simpson is going to come up and do a demo. And we're not going to show you unlimited amounts of data, because we don't have unlimited amounts of data. But we will show you some pretty big data, and you can use your imagination as to how far that goes.
All right. 3 minutes for the demo. 3 minutes, perfect. That's all the time I need. Does everyone hear me okay? So what we're looking at here, this is our web-based user interface in 1010 data, and this is where we're going to be looking at the trillion-row spreadsheet, as Sandy discusses. We're particularly going to quickly look at data from the New York Stock Exchange. They house data from all U.S. exchanges, all trades that are executed every day throughout the U.S. And we have data dating back to 2003. So I'm just going to scroll down here, double-click on our table with the complete history of trades, again, dating back to 2003. And you can see that we're working in a spreadsheet here, but we're looking at 56, 57 billion rows of data. So again, this is the size of data that we like to work with. Despite the very large size, I can quickly say I want to look at maybe a particular subset of this table. So if I want to look at maybe trades just so far this year, I can use any of my fields, quickly filter down to, let's say, all dates that are greater than or equal to 2014, 01. And from our 56.5 billion rows, we're going to pull down just the billion rows, just the billion trades that have been executed thus far this year. All right, so beyond that, what I want to actually do is quickly, all right, so this is something that's already hosted, it's already on the system. What if I have some additional data that I want to pull in? So I had a little text file that we asked them to store on the system. It's just a flat tab limit text file. It lists out all the tickers in the S&P 500. So we have 500 records here, and I am going to quickly pop open my folder browser on the left here. Every ID in the system can quickly upload their own data into my data folder. Click on my upload button, give this a little name here, and hopefully we're in the right folder. There we go, S&P 500. When I uploaded, I wanted the new, again, 500 row tables. Now we're doing things that are perfectly fine in Excel, but we can quickly actually bring this in with the data we already have. So if I actually, here's my new table, can open it up. Again, same kind of spreadsheet interface. We have our ticker, we have the company name. This GICS sector might be interesting. This is interesting. This is kind of like the industry under which it falls, so we can quickly get a breakdown of all the industries in the S&P 500. But again, let's go back to our history of trades, again, the billion records from this year thus far, and let's actually link in that data. So I'm going to link in this table I just uploaded. I can bring in any table I have access to in the entire system, including the one I just uploaded and actually already have open. So you see the S&P 500 is linked down here at the bottom. I can link based on any fields. Again, it's really as open-ended as you want it to be. Basically just doing like a VLOOKUP for an Excel, but we're doing a link on symbol to symbol. I'm doing a link in select, so we're only going to keep the rows that actually have a match. So we're going to just filter out only trades from of stocks in the S&P 500. So again, we have 16 columns, just over a billion rows. I click on Finish, and we will quickly pull in, there we go, up to 22 columns down to the 400 million rows that had a match. We have all those fields linked in, and now I can kind of aggregate further. If I want to do a quick aggregation, so we can break out by a couple dimensions, kind of like a pivot table. I'm going to break out with just one row per day quickly. All of our fields that are linked in from that foreign table are also options. So let's just click on that GICS sector. We'll get a column per industry. All right, let's just hit submit real quick. So if I just want to do a quick weighted average price, weighted by our volume, get our average price per share. And this will bring us down to our final result set. So here you go. Again, even though this data was just loaded in on the fly, linked into a table of 56 billion rows to start, we can still get down to our kind of final aggregate summary set very quickly.
Okay. Terrific. Thank you very much. So we unfortunately, that's all the time we have in terms of questions, but you guys are going to be around after this? All right. Thank you so much.
Thank you.